All right, guys, we're going to start Module 2 now. Lesson 2.1 is on angles and congruence. We're going to be looking at, labeling angles, how to correctly name them, how to measure them, classify them, and then we're going to look at some of the combinations of angles that we will use to describe various situations. All right, so first of all, looking at some basic terms, we're going to start with array. And we've already talked about it, but array is a part of a line that starts at an endpoint and extends infinitely in one direction. So array looks like this. All right, so here we have endpoint A. We're extending through point B. We go infinitely in this direction. All right, the way we would correctly write it is ray AB. Notice that the symbol above AB, the endpoint of this ray symbol is above the A, which is the endpoint, and it's extending through B, which is the point, another point that's on this ray. All right, now we could call it ray BA and flip this around. That's still actually correct, but I mean, I would write it as it looks. You're starting left to right at A and going through B. I'd start at A and go through B. So they're both right. This is probably the most clear way to do it. Okay, there's this thing called opposite rays, and these are two collinear rays. So collinear means they're rays that are on the same line and they have a common endpoint. All right, collinear rays, or actually I should say opposite rays, form a straight, what we call a pair or a straight angle, and that's got a measure of 180 degrees. So, this is a straight line, and we should all know that this, if I was to measure the angle here, it would be 180 degrees. We can look at it though as a pair of opposite rays, ray B through A and ray B through C are the opposite rays that we have here. So they share a common point, endpoint, and they travel in opposite directions. Okay, so we get to the idea of an angle. All right, an angle is defined as the intersection of two non-collinear rays at a common endpoint. Okay, so here we go. This is an angle for us to look at to start with. Okay, notice that it's made up of ray Y through X and ray Y through Z. Okay, the sides of an angle are the rays that make the angle. So sides of the angle be ray Y through X and ray Y through Z. The vertex is that common point they share. So Y is the vertex of this angle. All right, so the vertex is a common point they share, and the sides of the angle are the rays that make the angle. Now, when we name this angle, we can do this one several different ways. You can name it with 3 points, so X, Y, Z. And the way you name it, the vertex has got to be in the middle. If I was to trace from X to Y to Z, I need to create the angle. All right, so X, Y, Z is the angle. I could call it angle ZYX, same exact angle. We could call this one angle Y. We can name it by its vertex if there's only one angle at the vertex. So there is no other angle here. So it's just angle Y. We could call it that. And a lot of times they'll put a number in here and we can reference it by that. So angle 1. Okay, actually that's the easiest way to do it is to have numbers in there. Then you're not trying to trace the letters to find what angle they're talking about. Okay, some of the questions you'll get tonight. So use the figure and follow the directions. So question A asks for the vertex of angle 1. So looking at this drawing here quick, I guess, let's talk about what we have. Angle 1, okay, is obviously if I trace these two rays, QT and QR, that gives me angle 1. I have another angle here, which is angle 2, which would be RQ and S make angle 2. And then actually there's a third angle in the drawing, which would be angle TQS that encompasses both of those two. So there's actually 3 angles in the drawing. Okay, so they first of all ask us for the vertex of angle 1. The vertex of angle 1 is the point that the two rays have in common, so that's going to be Q. Actually, the vertex of all 3 of the angles I talked about is Q. Name the sides of TQR. So TQR is this angle 1, another way of naming it. The sides, remember, are rays. So we got we got ray Q through T, and we got ray Q through R. Those are the 2 sides that make up this angle. And then letter C here, write 2 other names for angle 2. So the 2 other ways we could name angle 2 would be angle RQS and SQR. Okay. Now, we cannot just name it angle Q because, as I talked about, angle Q could be three different angles. So that's not specific enough. We wanted to name this one particularly, so we got to use three letters or we got to use the number. Okay. So you get some of those. All right. The next thing we got to be able to do, we got to be able to identify where points are in relation to a angle drawn in a plane. So when I put an draw an angle, okay, remember that this is a ray that extends endlessly, and GH extends endlessly. So if I think of the plane as this computer screen, then this angle cuts the plane into three different categories. Okay, one category would be the points that are on the angle itself. Okay, so any point that's on these or rays would be considered points on the angle. So in this case, F, G, and H would be points on the angle. The other category would be points on the interior of the angle. So they have to lie in between the two rays. All right, so remember, this extends on endlessly forever. So in our case here, the points that are inside or interior points of the angle would be I and J. And then there's points that are exterior to the angle. Okay, so the angles that are on the outside of it, so to speak. And in this case, it would be K and L. So remember, when an angle is drawn in a plane, it divides it into three distinct parts. Okay, the points can be on the angle, inside the angle, outside the angle. Okay. Okay, the next thing we want to do is be able to measure and draw angles. Now, I'm sure you guys can already do this, but I'm going to go through it anyway because I think it's important that we all know this and can do it correctly. So we're going to be asked, first of all, to use a protractor to find the degree measure of the angle. All right, and you're going to be able to use manipulatives today on the Alex program. I'm going to have to do it a little differently here. But essentially, when we're asked to find the degree measure of an angle, we need to put our protractor on the angle so that the vertex is right here at this crosshair, if you will, and that one of the rays is running right down that line at zero. So if I was to take this protractor and put it on here, notice that the crosshairs right here are right on the vertex, and then I'm extending right down this line. So the way that we extend is the zero that we're going to reference. So in this case, I extend this way. So I'm going to use the inside set of numbers because that's where the zero is. So as I move from this ray to the other ray, I'm going to go 10, 20, 30, 40, 50, I don't know, about 56 degrees. So we would say this angle is 56 degrees. Okay. Over here, I take my other angle, I put my crosshair here right on the vertex, and I put the ray going right down the zero line. Now notice that this time, since the ray is going to the left, I'm going to use the outside set of numbers because that's where the zero is. We always work off of the zero that's on that ray. So 10, 20, 30, 40, 50, all the way over to 130, about 132 degrees is what this angle would be considered. All right, so that's how we measure angles. Put the protractor right on it, put the crosshair right at the vertex, and then you got to reference the zero as to which way the ray is extended. Okay, you're also going to be asked to draw angles today. All right, so if it says draw a 125 degree angle using the ruler and a protractor, and again, you're going to have manipulatives that you can use on the Alex site. But here's how we would do it. The first thing you got to do to draw an angle is to start with a ray. We're going to build our angle off of this ray. All right, so here's my ray. This is right where the end point is. All right, the next thing I'm going to do is place my protractor on it so that the crosshairs right here is right at the vertex or the end point of my ray. It's going to become the vertex of the angle. Okay, now this is my zero because I'm going to the right and I run into the zero. This is the zero. So I'm going to go 125 using the inside numbers. So I get over to 125. You're going to take out the pencil tool and you're going to make a little mark right here at 125 on the outside of the protractor. Okay, then I'm going to get rid of those two, get out a straight edge, and draw my line. Okay, that's going to be 125 degrees. Okay, we'll do it again, draw a 35 degree angle. So again, we'll start with the ray, put our protractor on the ray. Now I'm going from the end point extending to the right. Right there's my 0, 35 degrees. So I'm going to use the inside track of numbers here. So I'm going to get up to 35, take my pencil and put a little mark there at 35. Now I can move my protractor and pencil, use my straight edge here, draw in my ray, and there's a 35-degree angle. Okay, so that's how we go about doing that. So you'll be asked to measure some or draw some today as well. Okay, finishing up here with a couple more ideas. So the measure of an angle is always going to fall into one of 4 categories. It's really 3 categories, but I'm sticking this last one on just in case they put it in there. It can be an acute angle. Okay, an acute angle has a measure between 0 and 90 degrees. It's not 0 or you don't have an angle. That's why it's greater than 0. And it's not 90 or it's a different type of angle. So it's got to be somewhere between 0 and 90. Okay, and these are called acute angles. So if you look at this angle drawn right here, they're referencing a 90-degree angle to show you that this one is less than 90. All right, so this angle is less than 90 degrees. It's more than 0, so that's really the angle we're looking at. So that's an acute angle. Okay, a right angle has a measure that's exactly 90 degrees. We use right angles a lot. All right, so here is a right angle. Notice they put this little square in the corner. Whenever there's a square in the corner, that's telling you that that's exactly 90 degrees. We have obtuse angles. Obtuse angles measure between 90 and 180, not 90, not 180, somewhere in between. Okay. And obtuse angles, again, they reference a right angle here and show you that the angle opens past 90. So now we know that that is an obtuse angle. And then the last one I threw in here are straight angles. Straight angles we already talked about today. They're angles who measure 180. Basically, they're a straight line. Okay, so this is a straight angle, if you will. You know, ray AC and ray AB are opposite rays. That makes a straight angle. I've seen them use it, so I want to make sure we're prepared. Okay, now classifying angles. Here's the type of question you're going to get tonight. You got a choice between right acute obtuse. So angle A, if I come over here, angle A, notice there's only one angle at vertex A here, and that's this 70 degrees. Well, 70 degrees is between 0 and 90, so that's acute. Angle B is up here. Notice angle B is 140 degrees, so that is obtuse. Angle C up here is 60. That's between 0 and 90, so that is acute. And then angle D here is 90 degrees on the nose, so that means that is a right angle. So pretty straightforward there. Okay. A few more terms and definitions that you're going to see tonight. A linear pair. What does it mean when you have a linear pair? Well, what a linear pair is a pair of adjacent angles with a non-common side that are opposite rays. So essentially, and they are supplementary, means together they equal 180 degrees. Okay, so essentially this is what you're looking for. So if you look at angle 1 and angle 2 in the drawing, they share this common side that makes them adjacent. Okay, and their non-common side, which would be this ray and this ray, they make a straight line. All right, so if you put angle 1 and angle 2 together, they make 180 degrees, which is a straight line. So these two are a linear pair. When you put them together and they make a straight line here, you got a linear pair. Here's an example of nonlinear pair. So if you look at angle CDA, so CDA is this angle, and ADB, this angle, they're adjacent because they share a common side, but their non-common sides, which would be D to C and D to B, don't make a straight line. So that's not a linear pair. Okay, that's how that works. Vertical angles. All right, vertical angles are the two non-adjacent angles formed by intersecting lines. So it's the angles that are across from each other when lines intersect. So something like this. So if I got these two lines intersecting, angle 1 and angle 2 are vertical, angle 3 and angle 4 are vertical. And vertical angles, guys, are always congruent. They're always the same measure. So whatever the measure of angle 1 is, angle 2 is also the same measure. Whatever 3 is, 4 is the same measure. And if you're also thinking of linear pairs, you can see 1 and 3 make a linear pair, 1 and 4 make a linear pair, 2 and 4, 2 and 3. So you got 4 different linear pairs there, as well as some vertical angles. Okay, this is an example of a pair of angles that are not vertical. If you look at AEB, this angle, and DEC, this angle, those are not vertical. And the reason is because when you match up vertical angles, the two rays that make the angles need to make two straight lines. And EB and ED are not a straight line. So that means the two angles opposite are not vertical. Okay. Here's a question on this concept. So here's my drawing. I got lines L and M and line N. And by the way, we'll also name lines using a lowercase letter like this. And they've labeled these different angles. So the question says, name one pair of angles that form a linear pair. All right, so I'm looking up here at my drawing, angles 1 and angle 2. See how 1 and 2, angle 1 is made up of these two rays and angle 2 of these two rays, so they share a common side, and their non-common side is a straight line. All right, now there's actually a whole bunch of linear pairs up here. Okay, angle 2 and 3 make a linear pair, angle 3 and 4 make a linear pair, and angle 4 and 1 make a linear pair. So there's 4 different linear pairs here, and there's also 4 over here, right? 5 and 6 are a linear pair, 6 and 7, 7 and 8, 8 and 5. So you got your choice of these 8 different linear pairs. You only had to pick one. Okay, question B, name a pair of vertical angles. So if I just have to name one pair, 1 and 3 are vertical. Okay, you got these set of straight lines that intersect. 1 and 3 are across from each other. Well, 2 and 4 are also across from each other. If I come over here, 5 and 7 and 6 and 8, these are all vertical angles. You only had to pick one. Part C says, name a pair of angles that are congruent. Well, if you remember what we said in the last slide, all vertical angles are also congruent. So any one of these pairs of vertical angles are also going to have the same exact measure. Alrighty, so that's kind of a rundown of the basics of angles and congruence. All right, if you go to McGraw-Hill site, you're looking for more information or more examples, go to the McGraw-Hill site, log in, go to lesson 2.1 and launch it. And there's more examples that you can look at. And also be sure, guys, that you get the homework completed that goes with today's assignment. All right, I'll let you get at it.